All right, for review problem 3.25, this concerns two random variables that are not identically distributed, but they are uniformly distributed. So U1 is between 0 and 2, and U2 is between 0 and 3. So let's plot this. So U1 will be down here, and U2 will be up here. U1 goes from 0 to 2, while U2 goes from 0 to 3. Find the chance that U2 is less than or equal to U1 squared. So if I draw that plot of basically y equals x squared, that's going to look like this. So let me draw in the rest of the triangle, the rectangle here, and that's the graph of y equals x squared. Okay, now notice, of course, that it doesn't go through the corner of the rectangle. This point here is going to be located at square root of 3, which is a little bit less than 2. So find the probability that U2 is less than or equal to U1 squared. Find the probability of being in here. Now, technically, I could do a double integral over the joint PDF, but this one is uniformly distributed, so all I have to do is compare areas. So the area of the shaded region is going to be integral from 0 to square root of 3 of x squared dx. That's going to be this part, plus the rectangle over here. Now I'll set it up as an integral, but clearly it's just a rectangle. The height is 3 dx. Okay, so I get x cubed over 3, evaluated from square root of 3 to 0. Then 3x from 2 to square root of 3. So plugging in, I get 3 times square root of 3 minus 0 over 3. Plugging in here, I get 3 times 2 minus square root of 3, where this last term is just clearly the area of this small rectangle that appears here on the right side. Okay, so I can simplify this a bit, and I get 6 minus 2 square root of 3. Because 3's cancel here. Square root of 3 minus 3 square root of 3 is 2 square root of 3. So therefore, the probability in question, the probability that U1 or U2 is less than or equal to U1 squared, that'll be equal to the area divided by the total area of this rectangle, which is 2 times 3 for 6. So 1 minus square root of 3 over 3, and that will be the probability of being inside of that region.